Which of the following statements best describes the use of the ball tree data structure in A. Scikit-learn sklearn library? A. It is primarily used for clustering data points based on their spatial relationships. B. It facilitates the efficient computation of distances between data points in high-dimensional spaces. C. It is a core component of the k-nearest neighbors (KNN) algorithm, enabling efficient nearest neighbor searches. D. All of the above. Correct. Ball tree can be used for clustering algorithms like DBSCAN or optics, which rely on distance-based relationships. It partitions data based on spatial proximity, aiding clustering. However, ball tree is not limited to just clustering. Clustering ball tree can be used for clustering algorithms, particularly those that rely on distance-based relationships. Its ability to partition data based on spatial proximity makes it suitable for algorithms like DBSCAN or optics. Correct. Ball tree excels at distance calculations in high-dimensional spaces. It partitions data into regions balls and organizes them in a tree structure, enabling faster distance computations. Efficient distance computations. Ball tree excels at calculating distances between data points, especially in high-dimensional spaces. It achieves this by partitioning the data space into regions balls and organizing them in a tree structure. Correct. Ball tree is crucial for KNN, enabling efficient nearest neighbor searches. It speeds up the process of finding the k closest data points to a given point. Nearest neighbor search. Ball tree is a fundamental component of the k-nearest neighbors KNN algorithm. It enables efficient search for the k-nearest neighbors of a given data point, significantly speeding up the KNN process. Correct. As all the above statements are true, this is the correct answer. Ball tree is versatile and supports efficient distance calculations, nearest neighbor searches, and clustering. Therefore, the correct answer is D. All of the above. D. All of the above. A data structure is a way of organizing data in a computer system. It defines how data is stored, retrieved, and manipulated. Arrays for storing lists of elements. Hash tables for efficient lookups. Trees for hierarchical data representation. Graphs for representing interconnected entities. A space partitioning data structure that organizes data points into a tree-like hierarchy. It is particularly useful for finding nearest neighbors in a high-dimensional space. Recommendation systems for suggesting similar products. Image recognition for finding similar images. Anomaly detection for identifying unusual data points. A non-parametric, lazy learning algorithm that classifies or regresses a new data point based on the k-nearest neighbors in the training data. Handwriting recognition, image classification, credit scoring. A task in unsupervised learning where the goal is to group similar data points together. Clustering algorithms identify patterns and structures within data without prior labels. Customer segmentation, document clustering, image segmentation. A popular Python library for machine learning, offering a wide range of algorithms, tools, and datasets. Building machine learning models for classification, regression, clustering, dimensionality reduction, and more. Real-world applications of ball tree and related concepts. Recommendation systems, image recognition, anomaly detection, pattern recognition. What is the primary use case of the KD tree data structure in the sklearn neighbors KD tree class? A. Fast nearest neighbor search. B. Dimensionality reduction. C. Data visualization. D. All of the above. A. Fast nearest neighbor search. Correct. The KD tree is inherently designed for efficiently finding the closest data points. It recursively partitions the data space into smaller regions based on a specific dimension, enabling rapid search for nearest neighbors in high-dimensional datasets. 1. Fast nearest neighbor search. KD tree excels at efficiently finding the nearest data points in high-dimensional spaces. It achieves this by recursively dividing the data space into smaller regions based on a specific dimension. B. Dimensionality reduction. Correct. KD tree's structure inherently contributes to dimensionality reduction. By organizing data points based on selected dimensions, it implicitly helps highlight the most important features, effectively reducing the dimensionality of the data. 2. Dimensionality reduction. The KD tree structure inherently helps in reducing dimensionality by organizing data points in a way that highlights the most important features. C. Data visualization. Correct. While not its primary function, KD tree can indirectly aid in data visualization. Its organization of data points provides insights into data distribution and clustering, which can be leveraged for visual representations. 3. Data visualization. While not a primary purpose, the KD tree structure can contribute to data visualization by providing insights into data distribution and clustering. D. All of the above. Correct. Given the explanations above, all the mentioned options: fast nearest neighbor search, dimensionality reduction, data visualization are valid use cases for the KD tree data structure, making this choice the most accurate. The KD tree data structure is a powerful tool used in various machine learning applications. Here's a breakdown of its key capabilities. D. All of the above. Nearest neighbor search. A fundamental problem in computer science and machine learning involving finding the data points closest to a given query point in a dataset. KD tree excels in providing efficient solutions for nearest neighbor search in high-dimensional spaces. Recommender systems finding similar items based on user preferences, e.g., recommending movies similar to those a user has watched. Image recognition identifying visually similar images based on extracted features. Anomaly detection identifying outlier data points that deviate significantly from the norm, e.g., detecting fraudulent transactions in financial data. Consider a dataset with points in 2D space 1, 2, 3, 4, 5, 6, 7, 8. If the query point is 2, 3, the nearest neighbor search would identify 3, 4 as the closest point to the query point. KD tree. A hierarchical data structure specifically designed for efficient nearest neighbor search in multi-dimensional spaces. It recursively partitions the data space into smaller regions based on selected dimensions, facilitating rapid search for nearby data points. Clustering grouping similar data points together based on proximity, e.g., identifying customer segments with similar buying habits. Machine learning algorithms used as a fundamental building block for k-nearest neighbors (KNN). Other algorithms that rely on efficient nearest neighbor search. In a 2D dataset, a KD tree would partition the space by dividing it along either the x-axis or y-axis at each level, recursively creating smaller regions with data points. This partitioning allows for efficient search for nearest neighbors by navigating through the tree structure based on the query point's coordinates. Dimensionality reduction. A set of techniques used to reduce the number of features dimensions in a dataset while preserving essential information. This can simplify data analysis, improve algorithm performance, and reduce storage requirements. Image recognition, reducing the dimensionality of image features to speed up recognition tasks. Text analysis, reducing the dimensionality of word representations to improve text classification. Models. Imagine a dataset with 100 features. Applying dimensionality reduction techniques can reduce the number of features to, say, 10, while retaining most of the original information. This can significantly improve the performance of machine learning algorithms that operate on high-dimensional data. Data visualization. The process of representing data graphically to gain insights, explore patterns, and communicate findings effectively. It involves choosing appropriate visualizations to highlight trends, relationships, and distributions within the data. Business analytics, visualizing sales data to identify trends and patterns. Scientific research, visualizing experimental data to support scientific hypotheses. A scatter plot can visualize the relationship between two variables, e.g., temperature vs. ice cream sales, while a histogram can represent the distribution of a single variable, e.g., the frequency of different car colors. sklearn, neighbors, KD tree. A class within the scikit-learn library that implements the KD tree data structure for efficient nearest neighbor search in Python. It provides methods for querying the tree and retrieving nearest neighbors for given query points. Recommendation systems, building recommendation systems using KNN algorithms that rely on efficient nearest neighbor search. Anomaly detection, detecting anomalies in time series data using KD tree-based outlier detection algorithms. Consider a dataset of customer purchase data with features like age, income, and product preferences. Using sklearn, neighbors, KD tree, you can efficiently find customers who are most similar to a given target customer based on these features, potentially informing targeted marketing campaigns. Which of the following is not a valid use case for using kernel density estimation (KDE) in scikit-learn's kernel density? A. Generating a probability distribution from a given dataset. B. Detecting anomalies or outliers in a dataset. C. Estimating the probability density of a random variable at a specific point. D. Building a predictive model for classification tasks. Estimating probability distribution, KDE, is used to generate a smooth probability distribution function that represents the underlying data distribution, effectively summarizing the data in a probabilistic manner. True. Anomaly detection, KDE can be used to identify outliers or unusual data points by comparing their density estimates with the general distribution. Points with low density estimates are considered potential anomalies. True. KDE directly calculates the probability density of a random variable at any given point, which is its fundamental purpose. True. KDE is not inherently designed for classification tasks, as it primarily focuses on density estimation and related tasks, while it can be used indirectly for classification by combining it with other techniques. It is not a core classification method. False. D. Building a predictive model for classification tasks. Density estimation. Density estimation aims to approximate the underlying probability distribution of a dataset, providing insights into the data's characteristics and patterns. Kernel function. A kernel function, such as Gaussian kernel, is used in KDE to define the shape and smoothness of the estimated density. Different kernels influence the outcome of the estimation. Bandwidth parameter. The bandwidth controls the smoothness of the density estimate. A larger bandwidth results in a smoother but less detailed estimate, while a smaller bandwidth leads to a more detailed but potentially noisy estimate. Anomaly detection. Anomaly detection aims to identify data points that deviate significantly from the expected patterns, potentially indicating errors, unusual events, or fraudulent activities. Estimating probability distribution. In finance, KDE can be used to estimate the probability distribution of stock prices, helping investors understand the likelihood of different price movements. Anomaly detection in time series. KDE can detect unusual spikes or dips in time series data, like network traffic or sensor readings, indicating potential network failures or system malfunctions. Image segmentation. KDE can be used to segment images by identifying regions of high and low density, separating objects from the background or different image components. Data visualization. KDE can create smooth, visually appealing plots that depict the underlying density of data, providing a better understanding of the data's structure and distribution. Which of the following is not a hyperparameter of the k-neighbors classifier in sklearn? A. N neighbors. B. Weights. C. Algorithm. D. Metric. This is a hyperparameter. It determines the number of nearest neighbors used to make a prediction. Incorrect. This is a hyperparameter. It specifies how each neighbor's influence is weighted in the classification. Incorrect. This is a hyperparameter. It determines the algorithm used to compute the nearest neighbors. This can be ball tree, KD tree, brute, or auto. Incorrect. This is a hyperparameter. It determines the distance metric used to calculate the proximity between data points. Common options include Minkowski, Euclidean, and Manhattan. Incorrect. All of the above are hyperparameters, parameters that control the learning process of a model. These are set before the model training process. In a customer segmentation model, you might adjust the number of clusters a hyperparameter to find the optimal grouping of customers. Let's say you have a model that predicts the price of a house based on its size. One hyperparameter could be the learning rate, which controls how quickly the model adjusts its weights during training. A higher learning rate might lead to faster learning but also risk overfitting, while a lower learning rate might result in slower learning but potentially better generalization. A non-parametric lazy learning algorithm that classifies data points based on their proximity to other data points. A k-neighbors classifier could be used to predict whether a customer will purchase a specific product based on their past purchase history and the purchase history of similar customers. Consider a dataset with two features x1 and x2 and a binary classification label y. You want to classify a new data point with features x12 and x23 using KNN with k3. The algorithm finds the three nearest neighbors to the new data point based on Euclidean distance. If two of the three neighbors have y1 and one has y0, the new data point would be classified as y1. The number of nearest neighbors to consider for classification. This directly impacts the complexity of the decision boundary and the model's susceptibility to outliers. In a customer segmentation model, the number of neighbors could determine how closely related customers need to be considered part of the same segment. If n neighbors is set to 5, the classifier will consider the 5 nearest data points to make a prediction. This means that the prediction is based on the majority class among those 5 neighbors. Weighing scheme used for each neighbor's influence. Uniform assigns equal weights to all neighbors, while distance gives more weight to closer neighbors. In a recommendation system, distance weighing might prioritize recommendations based on users who have similar tastes, giving more weight to the preferences of closer neighbors. With uniform weighing, each neighbor's vote counts equally, With distance weighing, neighbors that are closer to the new data point contribute more heavily to the prediction. Algorithm used to compute nearest neighbors. Ball tree and KD tree are efficient for high-dimensional data, while brute is simpler but may be less efficient. In image classification, where images have many features, our ball tree or KD tree algorithm can be used to speed up the search for nearest neighbors. For brute force, the algorithm calculates the distance to all other data points. For ball tree or KD tree, the algorithm constructs a hierarchical tree structure to efficiently find the nearest neighbors, without calculating the distance to every other point. Distance metric used to compute the proximity between data points. Minkowski is a general metric that includes Euclidean and Manhattan as special cases. In a customer segmentation model, using Manhattan distance might be more appropriate than Euclidean distance if the data is skewed or has many categorical features. For Euclidean distance, the distance between 2 points is the square root of the sum of squared differences between their features. For Manhattan distance, the distance is the sum of the absolute differences between their features. This code snippet demonstrates the implementation of a k-neighbors classifier in Python using sklearn. It loads the iris dataset, splits the data into training and testing sets, and then trains a k-neighbors classifier model. The model is then used to make predictions on the test data. This code example provides a practical starting point for applying k-neighbors classifier to real-world machine learning tasks. In this example, the code uses n-neighbors 5, weights uniform, algorithm auto, and metric Minkowski. The auto algorithm will select the best algorithm based on the data, and Minkowski distance with P2 will be used, which is equivalent to Euclidean distance. Which of the following is not a parameter of the k-neighbors regressor in sklearn? A. N-neighbors. B. Weights. C. Algorithm. D. Metric. E. All of the above. N-neighbors, the number of neighbors to use by default for k-neighbors queries. This is the core parameter that defines the number of closest points to consider for prediction. False. The parameter n-neighbors is used to specify the number of nearest neighbors to consider for prediction. It is a crucial parameter in k-neighbors regressor, and therefore it is not the correct answer. Weights weight function used in prediction. This parameter allows customizing how the influence of each neighbor is considered. False. The parameter weights defines how the influence of each neighbor is taken into account during prediction. It is an essential part of the k-neighbors regressor, making it an incorrect choice. Algorithm used to compute the nearest neighbors. This can be auto, ball tree, KD tree, brute. It determines how the algorithm efficiently searches for nearest neighbors. False. The parameter algorithm controls the method used to find the nearest neighbors, impacting the efficiency of the algorithm. It is a valid parameter of k-neighbors regressor, making it an incorrect answer. Metric, the distance metric to use for the tree. This controls how the distance between points is measured. Examples include Euclidean, Manhattan, Minkowski. False. The parameter metric defines how the distance between data points is calculated. It plays a significant role in determining which neighbors are closest, making it a valid parameter of k-neighbors regressor, and therefore an incorrect answer. Therefore, the correct answer is E. All of the above. True. All the choices A, B, C, and D are valid parameters of the k-neighbors regressor in sklearn. This makes the correct answer as A. All of the above. E. All of the above. LT font style quote font size 14px quote GT LTBGTK nearest neighbors algorithm LTBGT font TGT. This is a non-parametric, lazy learning algorithm used for both classification and regression. It predicts the output for a new data point based on the majority class for classification or average value for regression of its k nearest neighbors in the training data. The algorithm's simplicity and adaptability make it widely used for various applications. Recommending products to customers on e-commerce websites based on their past purchases and preferences. Classifying images based on their visual content, such as identifying different types of animals or objects in photographs. Predicting the probability of a customer clicking on an online advertisement based on their browsing history and demographics. In healthcare, predicting the risk of developing certain diseases based on a patient's medical history and lifestyle factors. Let's say we have a dataset with two features x1, x2 and a target variable y. We want to predict the value of y for a new data point x13, x22. If we use a k-neighbors regressor with k3, the algorithm will find the three closest neighbors to the new data point based on the Euclidean distance. It will then take the average value of the target variable y for these three neighbors as the prediction for the new data point. LT font style quote font size 14px quote GT LTBGT regression LTBGT LT font TGT. A type of supervised learning where the goal is to predict a continuous output variable based on input features. The model tries to establish a relationship between the input features and the output variable, allowing for predictions of future values. Predicting the price of a house based on its features like size, location, and number of bedrooms. Forecasting sales based on historical sales data, marketing campaigns, and economic indicators. Predicting the price of a stock based on various financial factors, such as company earnings, market trends, and economic conditions. Estimating the number of customers who will visit a store on a particular day based on historical data and weather patterns. Consider a dataset with a feature X representing the number of hours a student studies and a target variable Y representing the exam score. We can use a linear regression model to find a line that best fits the data points, representing the relationship between study hours and exam score. This line can then be used to predict the exam score for a new student based on their study hours. LT font style quote font size 14px quote GT LTBGT distance metrics LTBGT LT font GT. A function that measures the distance between 2 points in a multidimensional space. Different metrics are used depending on the nature of the data and the problem being solved. Common metrics include Euclidean distance, Manhattan distance, and Minkowski distance. In image processing, calculating the distance between pixels in an image for tasks like image segmentation or object recognition. In recommendation systems, determining the similarity between users or items based on their preferences or ratings. In clustering algorithms, grouping data points based on their similarity measured by distance metrics. In anomaly detection, identifying outliers in data by measuring their distance from the majority of data points. Euclidean distance between 2 points ax1, y1 and bx2. y2 is calculated as sqrt x2 x12 y2 y12. Manhattan distance is calculated as x2 x1 y2 y1. LT font style quote font size 14px quote GT LTBGT sklearn library LTBGT LT font TGT. A popular open source Python library for machine learning. It provides a comprehensive collection of algorithms for classification, regression, clustering, dimensionality reduction, model selection, and more, building machine learning models for various tasks, such as image classification, sentiment analysis, fraud detection, and predictive maintenance, implementing data preprocessing techniques, feature engineering, and model evaluation methods. Comparing the performance of different algorithms and choosing the best model for a specific problem. Developing custom machine learning pipelines for efficient workflow management. Sklearn provides the k-neighbors regressor class, which implements the k-nearest neighbor regression algorithm. We can use this class to train and evaluate a regression model on a dataset, making predictions on new data points. LT font style font size 14px GT LTBGT parameter tuning LTBGT LT font TGT. The process of adjusting the hyperparameters of a machine learning model to optimize its performance on a given task. This involves finding the best combination of parameter values that minimize the model's error or maximize its accuracy on unseen data. Improving the accuracy of a classification model by finding the optimal number of trees in a random forest or the learning rate in a gradient boosting model. Enhancing the generalization ability of a regression model by tuning parameters like a regularization strength or the number of hidden layers in a neural network. Optimizing the performance of a clustering algorithm by adjusting the number of clusters or a distance metric used. Experimenting with different parameter values to achieve the desired balance between bias and variance in a model. For a k-neighbors regressor, parameter tuning might involve experimenting with different values of n neighbors to find a optimal number of neighbors to consider for prediction. This could be done using techniques like grid search or cross-validation. LT font style font size 14px GT LTBGT model evaluation LTBGT LT font TGT. The process of assessing the performance of a trained machine learning model on unseen data. This helps determine how well the model generalizes to new instances and how reliable its predictions are. Evaluating the accuracy of a classification model using metrics like precision, recall, F1 score, and AUC. Assessing the performance of a regression model using metrics like mean squared error, root mean squared error, and R-squared. Comparing the performance of different models using statistical significance tests and hypothesis testing. Identifying potential overfitting or underfitting issues in a model and adjusting its parameters accordingly. To evaluate a k-neighbors regressor, we can use metrics like mean absolute error (MA), root mean squared error (RMSE), and R-squared on a holdout dataset. These metrics quantify how well the model predicts the target variable on unseen data. What is the primary purpose of sklearn's k-neighbors transformer? A. Dimensionality reduction. B. Feature scaling. C. Feature engineering. D. All of the above. Correct. K-neighbors transformer can reduce dimensionality by finding the k-nearest neighbors for each data point. This essentially transforms the data into a lower dimensional space, X0A. Dimensionality reduction. Correct. K-neighbors transformer performs feature scaling implicitly as it relies on distances between data points. Distances are sensitive to the scale of features, and the transformer inherently handles this scaling process, X0A. Feature scaling. Correct. By finding the k-nearest neighbors and transforming the data, k-neighbors transformer creates new features, which can be considered a form of feature engineering, X0A. Feature engineering. Correct. K-neighbors transformer is capable of all the mentioned functionalities: dimensionality reduction, feature scaling, and feature engineering. All of the above. D. All of the above. K-nearest neighbors KNN is a non-parametric machine learning algorithm used for both classification and regression. It works by finding the k-nearest neighbors to a given data point and using their labels or values to make a prediction. K-neighbors transformer is based on this principle. X0a. K-nearest neighbors. Distance metrics quantify the similarity or dissimilarity between data points. Examples include Euclidean distance, Manhattan distance, and cosine distance. K-neighbors transformer uses these metrics to determine the nearest neighbors. X0a. Distance metrics. Feature scaling ensures that all features have a similar range, preventing features with larger scales from dominating distance calculations. This is crucial for distance-based algorithms like KNN. Common methods include standardization and normalization. X0a. Feature scaling. Dimensionality reduction reduces the number of features in a dataset, aiming to simplify data analysis and improve model performance. Techniques like principal component analysis (PCA) and linear discriminant analysis (LDA) achieve this. K-neighbors transformer reduces dimensionality by creating a transformed space based on nearest neighbors. X0a. Dimensionality reduction. Feature engineering transforms raw data into features that are more informative and beneficial for machine learning models. This can involve creating new features from existing ones, combining features, or encoding categorical variables. K-neighbors transformer implicitly performs feature engineering by creating new features based on neighborhood relationships. X0a. Feature engineering. Preprocessing prepares data for machine learning algorithms by handling missing values, transforming data types, and scaling features. K-neighbors transformer is a preprocessing step, particularly for KNN algorithms, but its capabilities extend beyond that. X0a. Preprocessing. Data visualization uses visual representations to gain insights from data. Dimensionality reduction techniques, including K-neighbors transformer, can simplify complex data for effective visualization. X0a. Data visualization. Machine learning pipelines streamline the machine learning workflow by chaining multiple steps together, including preprocessing, model training, and evaluation. K-neighbors transformer can be incorporated into pipelines to automate the preprocessing process. X0a. Machine learning pipelines. K-neighbors transformer is a class in the sklearn neighbors module. It implements the K-neighbors transformer functionality, allowing you to apply the transformer to datasets. X0a. sklearn neighbors. K-neighbors transformer. The n-neighbors parameter controls the number of neighbors used in the transformation. It is a key parameter in K-neighbors transformer. X0a. N-neighbors. The weights parameter determines how the contributions of neighbors are weighted in K transformation. Common options include uniform weights equal contribution and distance weights neighbors closer to the target point have more influence. X0a. Weights. The algorithm parameter specifies the algorithm used to find the nearest neighbors. Options include auto, ball tree, KD tree, and brute. The choice depends on the size and dimensionality of the dataset and can influence the efficiency of the transformation. X0a. Algorithm. The leaf size parameter controls the size of the leaf nodes in ball tree or KD tree algorithms. This affects the performance of neighbor search and can be adjusted to balance speed and accuracy. X0a. Leaf size. The P parameter defines the Minkowski distance metric used in the transformation. P1 corresponds to Manhattan distance, P2 to Euclidean distance, and P infinity to Chebyshev distance. This parameter allows you to choose the distance metric appropriate for your dataset and application. X0a. P. The metric parameter specifies the distance metric used to determine nearest neighbors. This can be a predefined metric like Minkowski, Euclidean, or a user-defined function. The choice of metric should reflect the relationships between features in your dataset. X0a. Metric. The metric params parameter provides additional parameters to the chosen metric. This can be used to customize the behavior of the metric, such as specifying weights for different features. X0a. Metric params. The njobs parameter specifies the number of jobs to run in parallel for the transformation. If set to -1, it uses all available processes. This can speed up the transformation process, especially for large datasets. X0a. Njobs. The fit params parameter provides additional parameters to the fit method of the underlying neighbors estimator. This allows for customization during the transformation process. X0a. Fit params. Transformer mixin is a base class in sklearn that defines the transform method, which is used for data transformations. K-neighbors transformer inherits from this base class, enabling it to implement the transform method for data transformation. X0a. Transformer mixin. Which of the following statements is true regarding the local outlier factor LOF algorithm in sklearn? A. LOF identifies outliers based on the density of their nearest neighbors. B. It measures the local density deviation of a data point compared to its neighbors. CLOF is particularly effective in identifying outliers in high-dimensional data. D. All of the above. A. LOF identifies outliers based on the density of their nearest neighbors. True. This statement is true. LOF is a density-based outlier detection algorithm. It identifies outliers based on the density of their nearest neighbors. A data point is considered an outlier if it has a significantly lower density than its surrounding neighbors. Density-based outlier detection. B. It measures the local density deviation of a data point compared to its neighbors. True. This statement is true. LOF quantifies the local density deviation of a data point by comparing its density to the density of its neighbors. It calculates the ratio of the average density of the k nearest neighbors to the density of a data point itself. If this ratio is significantly greater than 1, it means the data point is less dense than its neighbors and is therefore more likely to be an outlier. Local density deviation. CLOF is particularly effective in identifying outliers in high-dimensional data. True. This statement is true. LOF is particularly effective in handling high-dimensional datasets, which are common in many real-world applications. Unlike some other outlier detection methods that struggle with high dimensionality, LOF is robust to the curse of dimensionality. It avoids the issue of distance metrics becoming meaningless in high dimensions by focusing on local densities. High-dimensional data. D. All of the above. True. This statement is true. As we've seen, statements A, B, and C accurately describe the workings of the LOF algorithm. Therefore, the correct answer is D. All of the above. LOF summary. D. All of the above. Density-based outlier detection. Density-based outlier detection algorithms identify outliers based on their density relative to their neighbors. Outliers are data points that have significantly lower density than their surrounding neighbors. These algorithms are particularly useful in datasets with clusters or non-uniform data distribution, where traditional distance-based outlier detection methods might struggle. Anomaly detection in sensor data identify faulty sensors or unusual readings in real time. Monitoring systems. Fraud detection in financial datasets detect suspicious transactions that deviate significantly from normal patterns. Network intrusion detection identify abnormal network traffic patterns that could indicate malicious activity. Imagine a dataset of customer spending habits. Most customers make purchases within a certain range, forming dense clusters. A customer who makes a purchase far outside this range would be considered an outlier, possibly indicating fraudulent activity. Local density deviation. The local outlier factor (LOF) measures the local density deviation of a data point by comparing its density to the density of its neighbors. The higher the LOF score, the more likely the data point is an outlier. It calculates the ratio of the average density of the k nearest neighbors to the density of a data point itself. If this ratio is significantly greater than 1, it means the data point is less dense than its neighbors and is therefore more likely to be an outlier. Fraud detection identify fraudulent transactions in financial datasets. Anomaly detection in sensor data detect faulty sensors or unusual readings in real-time monitoring systems. Outlier removal. Remove outliers from datasets before applying other machine learning algorithms to improve model performance and reduce noise. Consider a dataset of daily stock prices. A sudden drop in price for a particular stock might indicate a potential outlier. LOF would calculate the density of the stock price relative to its neighbors. And if it's significantly lower, it would be flagged as an outlier, suggesting an unusual event. High-dimensional data. LOF is robust to high-dimensional data, making it effective for identifying outliers in complex datasets with numerous features. High-dimensional datasets often pose challenges for outlier detection methods, as the curse of dimensionality can hinder distance metrics. LOF overcomes this by focusing on local densities rather than relying heavily on global distance calculations. Anomaly detection in healthcare data identify unusual patient profiles or rare diseases in complex medical datasets. Network intrusion detection detect malicious activity in network traffic based on various network features like IP addresses, protocols, and data payloads. Anomaly detection in financial markets identify abnormal stock price movements or unusual trading patterns in high-dimensional market data. In a dataset of customer behavior on a website, you might have hundreds of features capturing user actions, demographics, and purchase history. LOF can effectively identify outliers in this high-dimensional space, helping you discover unusual user behavior or potential fraudulent activity. LOF summary. The local outlier factor (LOF) is a robust outlier detection algorithm that leverages density-based principles. It effectively identifies outliers in high-dimensional data by comparing the local density of a data point to the density of its neighboring data points. This algorithm finds applications in diverse fields, from fraud detection to network security, providing a powerful tool for identifying anomalies and improving data quality. Fraud detection. Anomaly detection in sensor data. Network intrusion detection. Outlier removal. LOF is a versatile tool that can be applied to many different types of datasets, helping you understand the structure of your data and identify unusual events or patterns. Which statements are true regarding radius neighbors classifier in sklearn? A. Radius neighbors classifier is a lazy learning algorithm that makes predictions based on the nearest neighbors within a specified radius. B. It uses a distance metric like Euclidean to measure similarity between data points. C. The radius parameter determines the maximum distance from a query point to consider neighbors for classification. D. All of the above. This statement is true. Radius neighbors classifier is a lazy learning algorithm because it doesn't explicitly build a model. During training, it simply stores the training data and makes predictions during the prediction phase by finding similar data points neighbors within a defined radius around the query point. This is described in the block with the heading "Altfont." Calico 0000FF quotient radius neighbors classifier LT FontGTCO and its subsequent description. Altfont Sizeco 1 quotient radius neighbors classifier is a variation of KNN that considers all neighbors within a specified radius around the query point. It doesn't limit the number of neighbors but focuses on proximity to the query point. LT FontGTCO. Lazy learning. In a customer churn prediction model, where you have historical customer data, you can use radius neighbors classifier to identify customers similar to those who have churned in the past by looking within a specified radius of a new customer's features. The model can predict whether they are likely to churn. Let's say you have a dataset of customer spending habits, e.g., average monthly spend, number of transactions. You want to predict if a new customer is likely to be a high spender. Radius neighbors classifier would work by finding existing customers within a certain radius based on spending patterns and seeing if they are high spenders. If a majority of the neighbors are high spenders, the new customer is also predicted as a high spender. This statement is true. Radius neighbors classifier, like other distance-based algorithms, relies on a distance metric to calculate the similarity between data points. The Euclidean distance is a commonly used metric, but others like Manhattan distance can also be employed depending on the nature of the data. This is evident in the block Altfont Calico 0000FF quotient radius neighbors classifier LT FontGTCO. And the mention of BGTK-LT-BGT nearest neighbors. The choice of distance metric impacts a model's predictions by influencing how neighbors are identified. Distance metric. In an image recognition system, the distance metric could be used to compare pixel values between images. Images with similar pixel values, i.e., closer in distance, are considered more similar. Consider two data points AX1, Y1 and BX2, Y2. The Euclidean distance between them is calculated as SQRT x2 x12 y2 y12. In radius neighbors classifier, the radius parameter sets a threshold for this distance, considering neighbors that fall within this radius. This statement is true. The 39 radius 39 parameter is a crucial aspect of radius neighbors classifier. It defines the maximum distance from the query point, the new data point being classified to. Consider neighbors. Data points falling outside this radius are excluded from the prediction process. This is clearly stated in the block Altfont. Calico 0000FF quotient radius neighbors classifier LT FontGTCO and its description about BGTK LT BGT nearest neighbors. The value of the radius parameter directly influences the size of the neighborhood and thus the prediction results. Radius parameter. Imagine you are using radius neighbors classifier for a credit risk assessment. You might set a radius that encompasses customers with similar credit scores and loan amounts to predict the creditworthiness of a new applicant. Assume you have a radius set to 5 units. A new customer's data point is 3, 4. A neighbor at 7. 1 would be included because the Euclidean distance is SQRT 7, 3, 2, 1, 4, 2, 5. A neighbor at 10. 2 would be excluded because its distance is greater than 5. This statement is correct, since all the previous statements are true. The correct answer is D. All of the above. Radius neighbors classifier. Radius neighbors classifier can be used in various applications like recommendation systems, anomaly detection, and even in medical diagnosis to identify similar cases. In a data analysis project, you might be using radius neighbors classifier to identify clusters of customers with similar purchasing behavior. By adjusting the radius and metric parameters, you can fine-tune the model to accurately identify relevant neighbors and effectively segment customers. D. All of the above. Which of the following is not a characteristic of the radius neighbors regressor in sklearn? A. It uses a fixed radius around each query point to find neighbors. B. It is suitable for nonlinear relationships between features and target variables. C. It is less sensitive to outliers compared to k-neighbors regressor. D. All of the above. Correct. This is the fundamental principle behind radius neighbors regressor. It defines a specific radius around each data point query point and considers only those neighbors that fall within that radius. This approach differs from k-neighbors regressor, which determines the neighbors based on their proximity distance and the value of k. Correct. One of the strengths of radius neighbors regressor lies in its ability to effectively handle nonlinear relationships between features and target variables. By considering neighbors within a fixed radius, it can capture intricate patterns and dependencies that might not be easily represented by linear models. Correct. Radius neighbors regressor is generally more resilient to outliers compared to k-neighbors regressor. This is because it focuses on a fixed radius rather than the distance to a specified number of neighbors. In the presence of outliers, k-neighbors regressor could be influenced by those distant points, whereas radius neighbors regressor would only consider neighbors within the specified radius, effectively mitigating the impact of outliers. Incorrect. This choice is incorrect because all the preceding statements A, B, and C accurately describe the characteristics of radius neighbors regressor. D. All of the above. Radius neighbors regressor. A regression algorithm that utilizes a fixed radius around a query point to identify neighboring data points for prediction. It's particularly helpful for capturing nonlinear relationships between features and target variables. 1, 2, 3, 4, 5, 6, 7, 8, 10, 20, 30, 40, 4, 5, 2. The radius neighbors regressor would consider neighbors within a radius of 2 units around the query point 4, 5. These neighbors would be 3, 4 and 5, 6. The model would then make a prediction based on the target values of these neighbors. K-neighbors regressor. A regression algorithm that considers the k-nearest neighbors to a query point based on distance. The prediction is made by averaging the target values of those neighbors. 1, 2, 3, 4, 5, 6, 7, 8, 10, 20, 30, 40, 4, 5, 2. The k-neighbors regressor would identify the 2 nearest neighbors to the query point 4, 5, which are 3, 4 and 5, 6. The model would then predict the target value by averaging the target values of these neighbors to 3, 2, 2, 5. Non-parametric regression. a type of regression that does not make assumptions about the underlying relationship between features and the target variable. It instead relies on local neighborhoods in the data to make predictions. Examples of non-parametric regression algorithms include k-neighbors regressor, radius neighbors regressor, and decision trees. Outliers. Data points that deviate significantly from the general trend or distribution of the data. Outliers can have a substantial impact on the performance of regression models. In a dataset of house prices, a house with an extremely high price compared to others in the same neighborhood would be considered an outlier. Use cases. Radius neighbors regressor can be applied to various real-world scenarios involving nonlinear relationships and the need to mitigate the influence of outliers. Predicting house prices based on location and other features. Forecasting product sales based on seasonality and other factors. Estimating customer churn based on usage patterns and demographics. Predicting the price of a stock based on historical data. What does the radius neighbors regressor in sklearn use to predict target values for a new data point? A. It uses a fixed number of nearest neighbors. B. It uses all neighbors within a specified radius. C. It uses the k nearest neighbors. D. All of the above. Incorrect. This describes the k neighbors regressor, not the radius neighbors regressor. The k-neighbors regressor uses a fixed number of nearest neighbors k to predict the target value for a new data point. For example, if k is set to 5, it will consider the 5 nearest neighbors to make a prediction. K-neighbors regressor. Correct. The radius neighbors regressor in sklearn uses all neighbors within a specified radius to predict the target value for a new data point. It considers all data points within the given radius around the new data point to make a prediction. Radius neighbors regressor. Incorrect. This describes the k-neighbors regressor, not the radius neighbors regressor. The k-neighbors regressor uses the k nearest neighbors to predict the target value for a new data point. For example, if k is set to 5, it will consider the 5 nearest neighbors to make a prediction. Incorrect. Only option B is correct. Options A and C describe the k-neighbors regressor. B. It uses all neighbors within a specified radius. The radius neighbors regressor in sklearn is a machine learning algorithm that uses the neighbors within a specified radius of a query point to make predictions. It's a non-parametric method, meaning it does not make assumptions about the underlying distribution of data. Predicting house prices based on nearby houses within a certain distance. Estimating customer lifetime value based on similar customers within a certain radius of influence. Forecasting sales by considering sales of nearby stores or regions within a specific radius. 1.5. 100. 2.0. 120. 3.5. 150. 4.0. 180. 2.5. 2.2. The radius neighbors regressor would consider the first two data points with distances 1.5 and 2.0 as they fall within the radius of 2.5. The algorithm would use these two data points to make a prediction for the new data point with a distance of 2.2. Nearest neighbors is a non-parametric machine learning algorithm that uses the k nearest neighbors of a query point to make predictions. It's a simple yet powerful algorithm that is widely used for classification and regression tasks. Regression is a statistical method used to predict a continuous target variable based on one or more independent variables. It aims to find a relationship between the variables and use it to make predictions. The radius neighbors regressor can be used to predict house prices based on nearby houses within a certain distance. This is useful for real estate agents and homeowners who want to understand the market value of their property. The radius neighbors regressor can be used to estimate customer lifetime value based on similar customers within a certain radius of influence. This is useful for businesses who want to understand the profitability of their customers and optimize their marketing strategies. The radius neighbors regressor can be used to forecast sales by considering sales of nearby stores or regions within a specific radius. This is useful for businesses who want to understand the impact of local factors on sales and make informed decisions about inventory and staffing. Which of the following statements best describes the purpose of the radius neighbors transformer in sklearn? A. It transforms data by calculating the distance from each data point to its nearest neighbors within a specified radius. B. It generates new features based on the density of data points in a specified radius around each data point. C. It uses the k-nearest neighbors algorithm to transform data into a new feature space. D. It scales the features of a dataset using the radius of a hypersphere around each data point. This choice is incorrect because the radius neighbors transformer does not directly calculate distances to nearest neighbors. Instead, it focuses on the number of neighbors within a specified radius. 6. This choice is correct. The radius neighbors transformer computes the density of neighboring data points within a specified radius around each data point. It does this by counting the number of neighbors within the radius and then using this count as a new feature for each data point. 7. This choice is incorrect. The radius neighbors transformer is different from the k-neighbors transformer, which is based on the k-nearest neighbors algorithm. The radius neighbors transformer focuses on a specified radius rather than a fixed number of nearest neighbors. 8. This choice is incorrect. The radius neighbors transformer is not primarily about scaling features. It focuses on transforming data based on local neighborhood density. 9. B. It generates new features based on the density of data points in a specified radius around each data point. 7. The radius neighbors transformer is based on the idea of density estimation. It measures the density of data points around each point by counting neighbors within a specified radius. 16. This transformation is effective for applications that rely on information about the local neighborhoods of data points, such as anomaly detection. 18. The radius parameter determines the size of the neighborhood considered for each data point. It is a critical hyperparameter influencing the transformation results. 20. Identify outliers in data by finding data points with few neighbors within a specified radius. 23. Group pixels based on their local density in images by calculating the number of neighboring pixels within a certain radius. 25. Derive new features that capture local neighborhood information for use in machine learning models. 27. Suppose we have data points in a 2D space 1, 2, 3, 4, 5, 6, 7, 8. Let's say our radius is 2.0. For the point 3, 4, the radius neighbors transformer would find its neighbors within a radius of 2.0. In this case, the neighbors would be 1, 2 and 5, 6. The transformer would then generate a new feature for 3, 4 representing the number of neighbors found within the radius, which would be 2 in this example. 13. From sklearn, neighbors import radius neighbors transformer. Transformer radius neighbors transformer radius 1.0. Metric Euclidean. Transformed data transformer, fit transform data. 29. Which of the following is not a characteristic of the nearest centroid classifier in scikit-learn? A. It's a simple and efficient classifier. B. It uses the mean of each class as the centroid. C. It assigns a data point to the class with the closest centroid. D. It's known for high accuracy in complex datasets. Correct. Nearest centroid is indeed a simple and efficient classifier. It's computationally lightweight. A. It's a simple and efficient classifier. Correct. The centroid is calculated as the mean of all data points belonging to a class. B. It uses the mean of each class as the centroid. Correct. This is the core principle of the nearest centroid classifier. It assigns a data point to the class whose centroid is closest to the data point. C. It assigns a data point to the class with the closest centroid. Incorrect. Nearest centroid is generally not known for high accuracy in complex datasets with intricate decision boundaries. It's better suited for simpler data. D. It's known for high accuracy in complex datasets. D. Represent the average point for all data points belonging to a particular class. Imagine you have two classes of fruits, apples and oranges. The centroid for the apples class would be a point in the apple feature space that represents the average characteristics of all apples in your dataset. Represent the average point for all data points belonging to a particular class. Finding the closest data points in a feature space, often based on Euclidean distance. Let's say you want to classify a new fruit. You calculate the distance of this fruit to the centroid of apples and the centroid of oranges. The fruit is classified as the type whose centroid is closer. Finding the closest data points in a feature space, often based on Euclidean distance. Assigning a label class to a data point based on its proximity to centroids. In our fruit example, if the new fruit is closer to the apple's centroid, it would be classified as an apple. Assigning a label class to a data point based on its proximity to centroids. A common metric for calculating distance between data points in multidimensional space. To calculate the distance between the new fruit and the apple's centroid, you can use the Euclidean distance formula, which considers all the features of the fruit and the centroid. A common metric for calculating distance between data points in multidimensional space. A popular Python library for machine learning, including various classification algorithms. You can use scikit-learn to implement various classification algorithms like nearest centroid, k-nearest neighbors, support vector machines, etc. A popular Python library for machine learning, including various classification algorithms. A specific classifier in scikit-learn that uses centroids for classification. In scikit-learn, you can create a nearest centroid classifier using the nearest centroid class and train it on your dataset to classify new data points. A specific classifier in scikit-learn that uses centroids for classification. For initial exploration of data or when you need a fast, baseline classifier. You want to quickly get a feel for the data before deploying more complex models. You can use nearest centroid as a simple classifier to get an initial understanding of the class. Separation in your dataset. 1. Quick prototyping for initial exploration of data or when you need a fast, baseline classifier. When computational resources are limited, nearest centroid's efficiency makes it suitable. You are working on a mobile application where computational resources are limited. Nearest centroid can be a good choice because of its low computational cost. 2. Low resource environments when computational resources are limited. Nearest centroid's efficiency makes it suitable. For datasets with well-separated clusters and clear boundaries, nearest centroid performs well. You have a data set of different types of flowers. The features are clearly distinct, making it easy to separate the different flower types. Nearest centroid would likely perform well on this dataset. 3. Simple data for datasets with well-separated clusters and clear boundaries. Nearest centroid performs well. You have a dataset of customer purchase history with features like age, income, and product categories purchased. You want to find customers similar to a specific customer based on their purchase behavior. Which sklearn's nearest neighbors algorithm would you use? A. K-neighbors classifier. B. K-neighbors regressor. C. Nearest neighbors. D. All of the above. K-neighbors classifier is used for classification tasks, predicting the class of a new data point based on its nearest neighbors. It assigns a class to the new data point based on the majority class among its neighbors. False. K-neighbors regressor is used for regression tasks, predicting the continuous value of a new data point based on its nearest neighbors. It predicts the value of the new data point based on the average value of its neighbors. False. Nearest neighbors is the most general algorithm and just finds the k-nearest neighbors to a given data point, without making any predictions. It's often used as a building block for other algorithms or for exploratory data analysis. False. All three algorithms are designed to find nearest neighbors in a dataset. However, they differ in their output and usage. True. D. All of the above. Finding data points that are closest to a given point based on distance metrics, e.g. Euclidean, Manhattan. Finding similar products, identify products similar to a given product based on their features or customer reviews. The number of nearest neighbors to consider for predictions. Recommending music movies suggests songs or movies based on the user's watching history. Measures used to calculate the distance between data points, e.g., Euclidean, Manhattan, cosine. Finding similar products, identify products similar to a given product based on their features or customer reviews. Predicting a categorical target variable, e.g., yes or no. Credit card fraud detection, identify fraudulent transactions based on the behavior of known fraudulent users. Predicting a continuous target variable, e.g., price, age. Predicting house prices, estimate the price of a new house based on the prices of similar houses in the neighborhood. For example, if you have a dataset of customer purchase history with age and income as features, and you want to classify customers into high spender or low spender based on their purchase behavior, you can use K-neighbors classifier. Let's say you have data like this. Age, income, spender. Dash 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 25500 high 30700 high 35400 low 40600 high 4580 high. Now, if you want to classify a new customer with age 32 and income 65,000, you can use K-neighbors classifier with K3 considering 3 nearest neighbors. The algorithm will find the 3 nearest neighbors to this new customer based on their age and income. If the majority of those 3 neighbors are high spenders, then the new customer will be classified as a high spender. Distance A, B SQRT A1 B12 A2 B22. For example, you have a dataset of customer purchase history with age, income and number of purchases as features, and you want to predict the number of purchases for a new customer with age 32 and income 65,000. You can use K-neighbors regressor. Let's say you have data like this. Age, income, number of purchases. Dash 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 25500010, 30700015, 354005, 406012, 458020. Now, the algorithm will find the k nearest neighbors to this new customer with age 32 and income 65,000. Let's say K3. It will then calculate the average number of purchases among those three neighbors, which will be the predicted number of purchases for the new customer. What is the primary purpose of scikit-learn's neighborhood components analysis (NCA) algorithm? A. To identify the optimal number of clusters in a dataset. B. To perform dimensionality reduction by finding a lower dimensional subspace that preserves neighborhood relationships. C. To select the most relevant features for a classification task. D. To classify data points into different categories based on their proximity to known examples. A. To identify the optimal number of clusters in a dataset. Incorrect. This is the purpose of clustering algorithms like k-means, not NCA. NCA focuses on preserving neighborhood structure, not finding clusters. Clustering algorithms. Customer segmentation, grouping customers based on their purchasing patterns, demographics, etc. To tailor marketing campaigns. Imagine you have a dataset of customer purchase data, each customer represented by their purchase history. Clustering can help you find groups of customers with similar buying habits. B. To perform dimensionality reduction by finding a lower dimensional subspace that preserves neighborhood relationships. Correct. NCA is a dimensionality reduction technique that aims to preserve the neighborhood structure of data points in a lower dimensional space. Dimensionality reduction. Image recognition, reducing the number of pixels in an image while retaining key features for faster processing. Consider a dataset of images, each represented by a vector of pixel values. Dimensionality reduction can project these images onto a lower dimensional space while preserving the essential visual information. C. To select the most relevant features for a classification task. Incorrect. Feature selection methods like recursive feature elimination (RFE) are used to identify the most relevant features. NCA focuses on preserving neighborhood relationships, not selecting features. Feature selection. Fraud detection, identifying the most impactful features like transaction amount, location, and time to build a more efficient fraud detection model. In a credit card fraud dataset, feature selection can help you prioritize features like transaction amount and location to build a model that effectively identifies fraudulent transactions. D. To classify data points into different categories based on their proximity to known examples. Incorrect. This describes the k-nearest neighbors (KNN) algorithm. NCA is a dimensionality reduction technique that prepares data for algorithms like KNN. K-nearest neighbors. Spam filtering, classifying emails as spam or not spam based on their similarity to known spam. Examples. Consider a dataset of emails labeled as spam or not spam. KNN can classify new emails based on their similarity to previously labeled examples. B. To perform dimensionality reduction by finding a lower dimensional subspace that preserves neighborhood relationships. What does the kneighbors graph function in sklearn's neighbors module do? A. Computes the k-nearest neighbors for each sample in the dataset. B. Returns a sparse graph representing the k-nearest neighbors for each sample. C. Calculates the distance between each sample and its k-nearest neighbors. D. All of the above. Partially correct. While the function does find the k-nearest neighbors, it goes beyond simply computing them. It constructs a graph representation of these neighbors. Correct. This is the primary function of k-neighbors graph. It constructs a sparse graph where each node represents a sample, and edges connect samples to their k nearest neighbors. The graph is represented as a sparse matrix, efficiently storing connections. Partially correct. The function implicitly calculates distances during the neighbor search, but its main output is the graph structure, not the distances themselves. Incorrect. While parts of the statement are true, the function's primary focus is on constructing the graph, not just computing distances or neighbors. B. Returns a sparse graph representing the k nearest neighbors for each sample. A supervised learning algorithm used for classification and regression. It predicts the class or value of a new data point based on the majority class or average value of its k nearest neighbors. Image classification determining the category of an image based on its similarity to known images. Recommendation systems suggesting items to users based on their preferences and the preferences of similar users. Fraud detection identifying suspicious transactions by comparing them to known fraudulent activities. A matrix where most of the elements are zero. Sparse matrices are efficient for storing and manipulating data with a high proportion of zeros. Like the adjacency matrix of a graph. Graph representation efficiently storing and representing connections in graphs, especially for large graphs with few connections. Natural language processing representing text data, where most words have low frequencies. Recommendation systems representing user preferences and item relationships with a high degree of sparsity. Functions that measure the distance or similarity between two data points. Common examples include Euclidean distance, Manhattan distance, and cosine similarity. Clustering grouping similar data points together based on their proximity to each other. Machine learning measuring the distance between data points to determine the optimal decision. Boundary or classify data points. Data visualization visualizing relationships between data points based on their distances. Algorithms that operate on graph structures, like the graph constructed by k-neighbors graph, for tasks such as node classification, community detection, and link prediction. Social network analysis identifying communities, influences, and relationships within social networks. Recommender systems predicting user preferences and recommending items based on graph connections. Fraud detection detecting anomalous patterns in networks, such as money laundering or fraudulent activity. 1, 2, 3, 4, 5, 6, 7, 8, 2. Consider a dataset with 4 samples, each represented by 2 features. We want to find the 2 nearest neighbors for each sample. Using k-neighbors graph, we would obtain a sparse graph representing the connections. For instance, sample 1, 1, 2 would be connected to samples 2, 3, 4 and 3, 5, 6, as they are its closest neighbors. The resulting graph could be represented as a sparse matrix where non-zero entries indicate connections between samples and their neighbors. What does the radius neighbors graph function in scikit-learn's neighbors module do? A. It calculates the distance between each data point and its k nearest neighbors. B. It constructs a graph where edges connect data points within a specified radius. C. It determines the optimal value of k for k nearest neighbors classification. D. It finds the nearest neighbors for a given data point based on a specified distance metric. This describes the functionality of the k-neighbors function in scikit-learn, not radius neighbors graph. K-neighbors finds the k nearest neighbors for each data point, while radius neighbors graph focuses on connections within a radius. False. A. It calculates the distance between each data point and its k nearest neighbors. This is the correct answer. Radius neighbors graph creates a graph where data points within a given radius of each other are connected by an edge. This is useful for tasks like clustering, anomaly detection, and semi-supervised learning. True. B. It constructs a graph where edges connect data points within a specified radius. This is not the function of radius neighbors graph. Determining the optimal k for k nearest neighbors is often done using cross-validation or other model selection techniques. Radius neighbors graph is focused on graph construction. False. C. It determines the optimal value of k for k nearest neighbors classification. This is similar to the functionality of kneighbors, not radius neighbors graph. Kneighbors finds the nearest neighbors for a given point, while radius neighbors graph builds a graph based on connections within a radius. False. D. It finds the nearest neighbors for a given data point based on a specified distance metric. B. It constructs a graph where edges connect data points within a specified radius. In radius-based neighborhood analysis, we define a neighborhood around a data point by considering all points within a specified distance. Radius. For example, if we have data points representing locations on a map, we might define a radius of 5 km to include all points within 5 km of a given location. Radius-based neighborhood defines a neighborhood as all data points within a specified radius from a given point. Graph construction involves representing relationships between data points as a network structure. In this context, data points become nodes vertices in the graph, and edges connect nodes that meet certain criteria, such as being within a specified radius of each other. Graph construction creates a network structure where data points are nodes, and edges represent relationships, e.g., within a specified radius. The adjacency matrix is a way to represent a graph numerically. It's a square matrix where each row and column corresponds to a node in the graph. The value in the cell at row I and column j indicates whether there's an edge connecting node I to node j1 for an edge, 0 for no edge. Adjacency matrix, a representation of the graph where each entry indicates the presence or absence of an edge between two nodes. Distance metrics quantify the dissimilarity between data points. Common distance metrics include Euclidean distance, the straight line distance between 2 points in Euclidean space. Manhattan distance, the distance between 2 points measured along the grid lines. Similar to navigating a city with perpendicular streets, the choice of distance metric depends on the nature of the data and the specific task. Distance metrics used to calculate distances between data points, e.g., Euclidean distance, Manhattan distance. From sklearn, neighbors import radius neighbors graph. Import numpy is np. Data np. Array 1, 2, 3, 4, 5, 6, 7, 8. Radius 2. Graph radius neighbors graph data. Radius. Mode connectivity. Print graph. To array. This code snippet demonstrates how to use radius neighbors graph to construct the graph from a set of data points. The data array represents the data points. Radius defines the neighborhood radius. And mode connectivity specifies that the graph should represent connections within the radius. The resulting graph is an adjacency matrix, which can be printed to visualize the connections. Code example. In clustering, radius neighbors graph can help identify clusters of data points by finding regions where data points are densely connected within a radius. Anomalies often appear as isolated points with few neighbors within the specified radius. For example, In a dataset of customer purchasing behavior, we might use radius neighbors graph to identify clusters of customers with similar buying patterns. Outliers might represent unusual purchasing habits or potential fraudulent activities. 1. Clustering and anomaly detection. Identify clusters of data points by finding regions of high connectivity. Anomalies often appear as isolated points with few neighbors within a specified radius. In semi-supervised learning, we have a limited amount of labeled data and a large amount of unlabeled data. Radius neighbors graph can help propagate labels from labeled data points to unlabeled points based on the graph connectivity. This can improve the performance of classification or regression models. For example, in image classification, we might have a small set of labeled images and a large set of unlabeled images. We can use radius neighbors graph to connect labeled and unlabeled images based on their visual similarity. By leveraging this graph, we can improve the accuracy of our image classification model. 2. Semi-supervised learning. Propagate labels from labeled data points to unlabeled points based on graph connectivity. This helps to improve classification or regression models with limited labeled data. Radius neighbors graph allows us to analyze the local structure of data by studying the relationships between neighbors within a specified radius. This can be helpful for understanding data patterns and identifying influential points. For instance, in social network analysis, we can use radius neighbors graph to analyze the relationships between individuals within a specific social circle. By analyzing the graph structure, we can identify influential individuals or discover patterns in social interactions. 3. Neighborhood analysis. Analyze the local structure of data by studying the relationships between neighbors within a specific radius. This can be useful for understanding data patterns and identifying influential points. What is the primary purpose of the sort graph by row values function in scikit-learn's k-neighbors classifier? A. To calculate the distances between all data points in the training set. B. To sort the neighbors of each data point in the training set based on their distances. C. To determine the optimal number of neighbors k for the k-neighbors classifier. D. To perform the actual classification of new data points based on their nearest neighbors. E. All of the above. 1. Distance calculation. The function's first step is to compute the distances between all data points in the training set, enabling the identification of the nearest neighbors for each point. True. 2. Neighbor sorting. It then sorts the neighbors of each data point in the training set based on their distances, making it easier to pinpoint the closest neighbors for future predictions. True. 3. K determination. This function also aids in determining the ideal number of neighbors k for k neighbors classifier, which can be fine-tuned through techniques like cross-validation. True. 4. Prediction. Finally, sort graph by row values is vital for the classification of new data points. It enables the k-neighbors classifier to identify the nearest neighbors of an unseen data point and predict its class based on the majority class among those neighbors. True. The sort graph by row values function within scikit-learn's k-neighbors classifier is multifaceted and plays a crucial role in the neighbor-based classification process. True. E. All of the above. The KNN algorithm is a supervised learning technique used for both classification and regression. It classifies data points based on the majority class of their k nearest neighbors in the feature space. In medical diagnosis, KNN can be used to predict the likelihood of a patient developing a certain disease based on their symptoms and characteristics compared to a database of similar patients. Distance metrics are used to measure the similarity or dissimilarity between data points. Common metrics include Euclidean distance, Manhattan distance, and cosine similarity. In a recommendation system, distance metrics can be used to find similar products based on user ratings or purchase history, helping suggest products that users might like. Cross-validation is a technique used to assess the performance of a machine learning model by splitting the data into multiple folds. The model is trained on a portion of the data and tested on the remaining folds to evaluate its generalization ability. In a financial forecasting model, cross-validation can be used to estimate how well the model will predict future stock prices based on historical data, ensuring the model is not overfitting to the training data. Hyperparameter tuning involves optimizing the values of parameters that control the learning process of a machine learning model, but are not learned from the data itself. In a spam filter, hyperparameter tuning can be used to adjust the thresholds for classifying emails as spam or legitimate, improving the accuracy of the filter. 1, 2, A, 3, 4, B, 5, 6, A, 7, 8, B, 4, 5. We can use the Euclidean distance to calculate the distance between the new data point and each point in the training set. SQRT 4, 1, 2, 5, 2, 2, SQRT 18 4.24. A. SQRT 4, 3, 2, 5, 4, 2, SQRT 2 1.41. B. SQRT 4, 5, 2, 5, 6, 2, SQRT 2 1.41. A. SQRT 4, 7, 2, 5, 8, 2, SQRT 18 4.24. B. Sorting the neighbors based on their distances gives us 0.2, 0.3, 0.1, 0.4. Assuming K3, the majority class among the three nearest neighbors 0.2, 0.3, 0.1 is A. Therefore, the K neighbors classifier would predict the class of the new data point as A.